All right, today's title of our webinar, we're going to be looking at a 12C new feature. This is the Synchronous Refresh for Materialized Views. Many of us are familiar with Materialized Views and have used those before, and we want to see what this new feature is all about today and how it is similar to Materialized Views as we know them and how it's also different from that. So we'll talk about that here. You can see, you should be able to see my slide here. I'm going to make sure everybody sees it all right there. You should be able to see the slide there. All right, my name is John Mullins, and I'll be your presenter today for this topic on Synchronous Refresh. You can see on this slide my email address. That's going to be your main way to send me questions. So even if you have questions about the webinar, send those to that address there. That's the best way to get them to me. I know in the past sometimes the webinar questions were sent to a different email address and that got a little bit confusing. So it's jmullins@themusinc.com. Make sure you send that. Related to that, you can go out for more information on things, you can go out to themusinc.com, the website. And on that website, you'll see a tab out there for webinars that that's where you can pick up copies of today's webinar. The slides should be out there now. And later on today or tomorrow, a recording of the presentation will be out there as well. Okay, so you can get copies of the slides and the recording of the presentation if you like. And past webinars, either Oracle related or DB2 or Java or whatever, they're available out there at that website as well. So feel free to go out there. There's lots of information. There are a lot of recordings of webinars out there, along with information about training and such that Themis provides. So let's go ahead and get jumped in here. I appreciate you joining me here on this Thursday. I know you're all very busy at this time of the year, so we'll get started. And again, if you have questions, send them to that email address. That's the best way I can get back to you very quickly with those. So let's go ahead and jump in and see what's going on with this new feature. All right, as we jump in here, just a little bit of overhead information for you. Again, my name's John Mullins. Thank you again for joining. I'm coming to you from Themis Inc. today. There's my email address again. Jot it down. So if you have questions, you can write those down during the course of the presentation today, jmullins@themusinc.com. I recognize a lot of the names and the people that are attending today. So many of you are familiar with my background and experience, and I've had you in classes before. So thank you again for coming back. Also, thanks to my friend Ken joining us from the Netherlands today. So he's our good evening type person today. I believe they're 7 hours ahead of us down there. All right, just a little bit about my background. As many of you know, I'm an Oracle Certified Professional DBA, also Certified Technical Trainer. So you're aware of how this particular webinar will be structured for you and such. And I've seen many of you in a lot of the different classes that I've taught over the years, whether it be SQL, PL SQL, or database administration related. So it's good to see you again here today. All right. So make sure I was checking questions there. Looks good. Remember, if you have questions, send them to my email address there. About Themis itself, again, many of you will be familiar with this, but if you're not, they've been around for a long time, teach lots of different classes, Oracle, of course, DB2, SQL Server, Linux, Java, other programming languages and such. So feel free to check out that website at themusinc.com and also check out information about prior webinars, including today's webinar at themusinc.com/webinars. All right, as far as this particular topic goes, this being a 12C new feature topic, here's some of the courses that we offer that would be related to that. So we have some new feature type courses that are targeted for developers. Some of you have taken those courses. I recognize your name there. And we also have the 12C new features for administrators as well. So feel free to check out that website for more information about those particular courses, including their outlines. As far as today goes, we're going to be looking at that synchronous refresh for materialized view. That's going to be our objective. Kind of what we want to do is become familiar with the process and the steps that are necessary to implement that particular feature. So that's what we'll focus on today. As far as an overview of the synchronous refresh, many of us are familiar with kind of the prior to 12c, how materialized views are used out there. In those particular methods, materialized view is usually used to capture results of queries, like from aggregate functions or your own functions, join type things. It's meant to reduce the amount of I/O that we have to process in order to get to a particular solution. It's involved with the query rewrite feature in Oracle. And so those materialized views, it's a physical thing. They take up space. We decide how often the data in the materialized view is refreshed. The process it goes through is we make changes to tables, and then based on our definition for the refresh rate, the materialized view is usually refreshed later after the changes to the table are made. With the synchronous refresh, however, the tables and the materialized view, they're refreshed at the same time. You can see here, look at that second bullet on there. It talks about this is well suited for certain types of environments. A lot of Oracle's new features over the years, a lot of times they'll say, hey, this feature is targeted for and works best in this type of environment. And that'll be like a data warehouse environment, an online transaction environment. These are good for batch type things. These are good for large transactions, small transactions, and so on. And so for this particular feature, Oracle will say, well, for data warehouse, okay, that's fine. But the part that I kind of took from their documentation there is the word controlled and periodic. What they're looking at here is think about the ETL process with a data warehouse, the extract, the transformation, and the load process. We extract data from various sources. It goes through different transformations and different formatting, and then we eventually load it into the process. We have multiple steps along the way for doing that, and that's typically done nightly, weekly, monthly, quarterly, whatever the definition is of our warehouse and how often that we want things to be updated. And those could be incremental refreshes. They can be full refreshes. This synchronous refreshes kind of follows along those steps. So keep that in mind. The key part here is controlled and periodic levels or intervals. We think about the old materialized views, and we define what those levels of refresh are, how often they get refreshed. Remember, we insert, update, or delete into the tables, and then the materialized view gets refreshed whenever we tell it to. In this case here, we're not going to be inserting, updating, and deleting into the tables at all. What we're going to have, and you'll see here in a few slides, is something called a staging log, which is very similar to a materialized view log. And the inserts, updates, and deletes are going to go against the staging logs. And that's why the controlled part is very important here. Because those staging logs, they're really just staging tables. And that's where that reference and kind of comparison to the ETL process comes into play here. So what we're going to have is the set of tables. When you think about the data warehouse, typically, it doesn't have to be this way, but typically we're going to have these fact tables. Like today, I'm going to use one that's going to have data about sales for different time periods. And then along those, surrounding those fact tables are a series of dimension tables. And time is usually one of those dimensions. Geographic type things like regions or states or countries or zip codes could be in there as well. So there could be lots of different dimensions by which we access, in this case, the sales data that I'm going to use in this example for today. The important thing that you'll want to take away from today is how this new feature fits in, where it fits in. It's not going to be for everybody. And also, what are the steps in the process? And the steps are important. The processing the steps in a certain order is important. And so we want to make sure that we take that away. So make sure you at least get a copy of the slides to take with you. Again, you can get those at themasync.com out there at the webinars tab. You can pick those out there. Now there's some requirements that are related to the synchronous refresh feature. Again, similar to remember, this is targeted for what it thinks it to be a data warehouse environment. It doesn't have to be a data warehouse. It could be like a hybrid between a data warehouse and an online transaction. But again, only certain types of processes are going to make sense for this feature. And when I think about this feature, is it a new feature? Is it a new option? Is it a new parameter setting? Is it a new command? What is it? I kind of think of it as almost like a new process that's available to us, because we can't just do one part of it and be done with it and get it to work. It's multiple steps. So to me, it's like an Oracle 12c. Instead of new feature, it's like a new process. And if we're already doing something like this a different way, this might be a better way. The synchronous refresh, one of its benefits is the refreshing of the data and being able to see the results from the materialized view is supposed to be a better performer, okay, because of the way that of the preparation for this process is done. So we're looking for better performance, with our materialized views and the refreshing of those materialized views with this new feature here. Now, I'd mentioned that this feature, one of the parts of it is these materialized views staging logs. And I had mentioned that they're very similar to materialized view logs that were used to prior to Oracle 12c. The staging logs are going to get created for us. Each of our tables, our fact tables, our dimension tables are going to have staging logs associated with them. The materialized view will as well. And the staging logs are going to contain the changes that have happened. So once we get this set up, tables are in place, the materialized view is in place, we go through the steps to set it up as a synchronous refresh, then the changes we need to be conscious, and this is the control part, the changes will be going against the staging logs, which are no more different than just tables. So we won't be applying the changes to the tables directly like we're used to. They'll be going against the staging logs. The staging logs have the same definition as the tables, except they have an additional column which indicates what was the action. Was it an insert? Was it an update? Was it a delete? And this will all make sense a little bit more as we start to go through the process here in just a few moments. Once a table has a staging log associated with it, you can no longer do inserts, updates, and deletes against the table until it gets unregistered from the staging log. Okay, if I create a table, dimension table like time, and a fact table, whatever it is, and I register those and I set them up with a synchronous refresh, if I go back and I try to do an insert, update, or delete against the regular database table, I'm going to get an error message at that time. It's actually an ORA-31917. And what the message actually says is illegal operation on a table which has been locked by synchronous refresh. Okay, so until I unregister that table from the staging log, I can't do inserts, updates, and deletes against it. Again, everything will be done against the staging logs, and they're going to use those staging logs. Those are very important to speed up the process when we eventually apply the changes through executing the refresh. Those staging logs will be important to the efficiency of that. So a little bit kind of the same, but a little bit different there as far as those logs are concerned. Now, Oracle is going to use a term as these tables and materialized views, they have to be registered with synchronous refresh. Okay, it's not just adding an option to a particular command and that makes that. We have to actually register it. It's going to write it to the data dictionary as being registered or associated or dependent upon these logs that are out there. It's a very simple step to do. As far as the tables go, we're going to just create a staging log for those tables, and that automatically registers them with synchronous refresh. And I'll show you how to do that here in just a few moments. The materialized view we're going to do with a procedure from a new package. So in Oracle, there's a new package called dbms_sync, SYNC_refresh. And within that package, there'll be a procedure that we'll use to register the materialized view. So the materialized view and the tables are registered differently, but it's still an easy process no matter which one we use there. Okay, so the idea behind the whole feature here is that we're looking for a way to synchronize the changes that come in against a group of tables that have been registered with synchronous refresh, so that the tables are updated and the materialized view is updated at the same time, and that's the new feature. Now this feature, lastly in the overview here, and then I'm going to jump into an example. The new feature here has basically two steps to it. It has a preparation step. So once all the tables are out there, the data's in there, and now we're doing normal processing, whatever. The first step is preparation, and that could be the longer of the two steps, depending on how many changes you have. Because what it's doing at that point, it's going out and gathering statistics on the data that's in the staging tables. You know, how many inserts were done, how many updates were done, how many deletes were done, things like that. And it's also doing a mapping of the partitions between the materialized view out there in the staging and the other partitions in the regular materialized view and in the fact tables that are out there, the partitions. So the preparation can take a while to do that. The execution then goes out based on the preparation part and actually does the actual refresh. So into any of the dimension tables, we're doing inserts, updates, and deletes. Typically, dimension tables don't change as much, let's say, as the fact tables that's out there. So in this case, like here, I'm going to have a fact table that's gathering sales data based on dates. And so, you know, the better my sales are, the more data I'm going to have. You know, the time dimensions, if we have location dimensions, which I won't have in this, or geographic dimensions, those won't have as much there. The execution, the part of it that makes it really fast is the fact the dimension tables don't have too many changes typically. The fact tables, or fact table will, however, since one of the requirements is these fact tables and materialized views have to have partitions, it's just doing a partition exchange between the change environment and the real environment. That's what makes that so fast. So even though I might have a bunch of changes, I'm not applying one change at a time. I'm exchanging partitions, which those of you that are very familiar with the different types of partitions out there know that that can be a very fast process as opposed to just doing an insert, update, delete. That's going to take some time for us to do. Now, as far as those partitions go, and we'll see some slides later on down here about this, but the synchronous refresh supports two types of partitions, range partitions and composite partitions. And the range partition has to be the highest level or the top level of the partitioning. So I have to start with the range partition, and then I can have a sub-partition under that, which could be a range partition as well, and so on. So it supports range partitions and composite partitions there. So hopefully that kind of gives us just a little bit of quick overview of what the feature is. Now, it's going to be a number of steps, and remember the end goal is we're going to refresh the tables and the materialized view at the same time, and hopefully in an efficient, timely manner as well. All right, to get started on this, there's kind of a prerequisite step. Okay, there's a table called sync_ref, SYNCREF _ table. That needs to be created ahead of time in whatever schema is going to be running the process. Okay, and that table can be the definite or the code to create that table is in a script supplied by Oracle called utlsrt.sql, and it's wherever the Oracle software is installed at Oracle Home RDBMS admin in that directory structure or that folder there, depending on which environment operating system you're running on. You just have to run it one time. It's going to contain results of some of the process steps. So we create this one time in the schema. If you're going to have multiple schemas that might be doing this, then you'll obviously need to create this table more than once in each schema for sure. Do it once, forget about it, you're done. All right, so we'll get that out of the way. All right, here's the tables I'm going to be using in the example today. So I'll go ahead here and go through the example for you step by step, explain each of the steps to you. You'll see this is a very simple thing to do. Remember, the important thing is these steps and this new feature is targeted for a certain type of process. Okay, so controlled, periodic inserts, updates, and deletes. Okay, it's not for the random, on the fly, even the application based during the day type of things, because the inserts, remember, and updates and deletes are going to be happening against staging tables, not database tables, real database tables or application tables, whatever you might want to call those. So here's my first table. I'm going to keep it very simple. I'm just going to have one fact table and one dimension table today. Typically, of course, we'd have many dimension tables out there related to this fact table. All right, and remember, along the way, if you come up with some questions, jot those down, and you're going to send those questions to jmullins@themasync.com. That's the best way in the kind of the time frame that we have today. All right, here's my first table. It's just called time dimension, or time_dim. It has a column called time key, which is just a date data type. This is going to represent the date of a particular sales transaction. I also threw in the month in there. We typically might have month, year, day in there, or something else, other dimensions related to time in here. So the first one is just date, like a day, month, year, whatever, and time. The second one is just the month from there. So it could be, if it's March is the date, the month could be a 3. It's just the numeric representation of the month there. That's all it is. All right, here's the big one here. Here's my fact table. That's why I call it sales_fact. So keep these two in mind here. That's why I try to keep them simple, to keep it easy to remember later down the road. It has a time key. That's going to, of course, going to be referencing the time key in the dimension table. And I might have the table. Looks like the table name there is not quite correct. Should be time_dimension there, I believe, right? Yeah, time_dm. I have those flip-flop there on that slide. That's okay. And then the dollar sales for that date and time. Okay, so we're just keeping track of, okay, I make a sale on a certain date and time, I insert it into the fact table, and so on and so on. So this fills up pretty quickly, hopefully, if I'm successful with my sales, that is. And this particular table has 2 partitions. We're doing a partition by range based on the date. And so the first one is just values less than, let's see, July 1st, 2016. And the second one is beyond that, up to some max value there. Okay, so I'm just putting them in there based on dates at this point in time. And we're not too worried about what this fact table looks like, because the materialized view will represent it as well. What we're really concerned with today is the process and how to implement the feature here. All right, so I got 2 tables, a dimension table with time and a fact table based on sales. All right, so let's go through the process of, I'm going to have a materialized view based on this sales table, this fact table as well. So what I'm going to do in that materialized view is I'm going to sum up the sales by date. Okay, that's going to be my materialized view. Obviously, we don't typically, store results of queries in regular tables, and that's kind of what the materialized view is for. Or if any of you are familiar with the result cache feature that was new in 11G, that's kind of like a materialized view in memory. Materialized view, the result cache, those are ways for us to kind of store results in a particular structure, so that when we do queries that demand those results from those types of things, like results of aggregates or results of your own functions or whatever, we can get the result from the materialized view through the query rewrite, and we don't have to recalculate it. Same thing with the result cache, and that's what makes those things much faster for us. So here, remember, the whole idea here is, when does this materialized view get refreshed? With the old way, we define when it gets refreshed. With the synchronous refresh, it gets refined or refreshed basically on demand when we tell it through these processes steps that I'm getting ready to go through. So those are my tables. Let's jump in here and get this thing started. First step is, of course, you got your tables are in place. I have a dimension table, I have a fact table. I haven't created the materialized view yet. So first thing I'm going to do is I'm going to create the staging logs for the tables that are involved with the materialized view. All right, so in this case here, this is a old command with a new option on it. So we say create materialized view. We give it a name, tell it what table it's on, for, and then here's the new option, synchronous refresh using, and then here's an important part, the staging table name. Now the nice thing about this is you don't have to create the staging table, it'll do it for you. Okay. So somebody creates the regular tables, dimension and fact. You run the create materialized view log with the synchronous refresh option for each table that's involved with your materialized view. So namely the dimension tables and the fact tables. Both of these will create the staging tables for your tables, and this is the same way that we register your tables with the synchronous refresh option. So when these two commands are done, you will no longer be able to do inserts, updates, and deletes against the real database tables, like in this case sales fact or time dimension. You will only be able to do inserts, updates, and deletes against the staging tables. Okay, until you either unregister them from the synchronous refresh or until you do an abort of the process as well. So this is step one, create the staging logs on the tables or for the tables. Okay, and you run that. Those are both very simple. Okay, once I've registered my tables with synchronous refresh, my second step is go ahead and create the materialized view. And you can see here's my command here. And like I said, you'll want to get a copy of these slides later on because these have the steps in the exact order and has some checking processes in between the steps. This is real good if you want to go back and try this yourself. All right, here's my create materialized view. Notice the partitions up here are exactly the same as my fact table. I'm doing a partition by range on the time key. I have two partitions just like the fact table. That's important. The materialized view has to be partitioned the same as the fact table that it's based upon. If it's not, you're going to get an error, not at this point necessarily, but when we go down the process to register the materialized view or we run it against, there's a checking process to see if our materialized view is in sync and is eligible with our fact table. If it isn't partitioned the same way, then those other processes down the road are going to fail. Okay? So it has to be partitioned the same. That's a rule. All right. It also has to use this using trusted constraints option on it as well. What that essentially says is, our fact table and our dimension tables, they're typically going to have foreign keys and primary keys on them. And this is just telling the materialized view definition as data is inserted, updated, or deleted against the materialized view, that we're going to trust the constraints that have already been defined for the real database tables. That's all it's saying. Now, when it comes time later on to do the refresh, these constraints are in place and they're associated with this materialized view. When we apply the changes like inserts, updates, or deletes to the materialized view data, they'll be applied with the constraints in no validate mode, which means the data that's already in there, we're not going to worry about it. We're only apply the constraints to the new data that comes in. That'll help speed up the process as well. And typically we'll do that for large inserts, updates, or deletes anyway, even just against a regular table, right? Here's what my materialized view is doing for me down here at the bottom. Okay. You can see, like I said before, I'm just getting the sum of the dollar sales or the sum of the sales by date and time. Okay, so I might have, here's a sale from something, here's a sale, and they might all be from March 8th. Okay, this is going to sum those all up, show you here's the date for March 8th and the sum of the sales for March 8th, which might be 50,000 transactions, or one transaction or no transaction. So you can see I'm doing that. I'm doing a join between the fact table and the dimension table, which would be typical, and doing a group by on the time there, or the date and time. So that's my materialized view. Okay, look at that. Keep that in mind there. Remember, it's partitioned just like the fact table, and we're doing a sum of the sales by time. Right? So we got our steps going there. So if we go back real quick, just see where we're at here. Our tables are in place. We create the staging logs for the tables. We create the materialized view. All right, and then we want to, once the materialized view is checked, then this is a kind of an optional step, but this is a real good step that I would recommend. There's a procedure called can sync ref table. What it's going to do, it's going to go out and take a look at your materialized view, what tables it's based upon, what options you have set up in it, like the trusted constraints and such, and make sure that it's following all the rules of the synchronous refresh feature. And if any of those violate any of the rules, like maybe you're trying to do a materialized view on a table without partitions. Being partitioned is a requirement. Maybe it's partitioned by list instead of range. That would be a problem. Maybe you have not registered one of the tables like we did earlier with the create materialized view log step. And it's going to do all those things, check the materialized view against the requirements, and then put the results in a table. Remember that table from earlier, the sync ref table that was created as a prerequisite? Put the results in there. All right, so here's how we would run it down here. Just execute the stored procedure. MV user 1 is just the schema. Sales fact is the fact table. And then MV1 is just a statement ID. That can be anything you want it to be. All right, we run that through there, and then if it's successful, it just comes straight back. It doesn't come back and say, hey, everything's cool. But if it fails, you'll get some error messages, plus it'll write error messages to that table, which then you can see on this next slide here, you can query. So here's the select from the sync ref table with the statement ID. Now this just shows one of the many messages that could show up there. So even if the previous step, making sure my fact table and materialized view were set up correctly, even if it was successful, it doesn't give me messages, but it writes the messages to this table. If it fails, you'll see them on the screen. So if it's successful, you may want to come to this table, take a look. This is just one of the messages. It's going to show you things like, okay, the time table is the dimension table. If you had a geographic table, it might say location is the dimension table. Here's the fact table. It's checking the joins on those types of things. It's checking for partitions. Like I said, all the things that it's checking for, and it puts them in here, and it has this eligible column up here at the top in this table, which will either be yes or no. So it's either going to tell you all the different things it checked for. At this point, you already know they were all maybe okay because you did not get an error on the previous step, but this will show you the details of that. And this is just one of those messages. The materialized view passes the join graph eligibility check for synchronous refresh. Like I said, it'll check for partitions, it'll check, make sure dimension tables are in line with the fact table and all that good stuff. So here's a reason why we create that table in the first place. If you forget to create the table in that prerequisite step and you get to this previous page here, this one right here on the can sync ref table, it's obviously going to give you an error message, and the error message isn't very clear as to what's going on. It makes it look like something hasn't been compiled. It makes it look like you've done some step out of order, but it doesn't say, hey, your sync ref table is missing, which would be a real good. But all of you, I don't need to tell you, because I know I've seen a lot of the names there. You've been using Oracle for a long time, that a lot of Oracle, just like any other vendor, error messages can be vague and a little bit difficult to understand. Okay, so remember, this step here is just optional. We're just making sure everything's set up. But it's a good thing to do, because these next steps, if they fail, this is going to kind of tell us why they might fail ahead of time. All right, now that we got to there, we've registered the tables, which means we have staging logs for the tables. We created the materialized view. We checked the materialized view in the fact table. All that looks good. Now we're ready to register the materialized view. And kind of unlike the tables, we're going to do this with a procedure. The name of the procedure is just register_mviews. We give it the materialized view name, which in this case is sales fact MV. And if he's able to when he registers this, along with when we registered the tables earlier, it creates a group ID based on the materialized view and the tables that it accesses and the tables that have already been registered. And these are all put into the same group. So right now, when this gets done, I've got tables and a materialized view that are all part of some registered group. And that's very important as far as the synchronous refresh goes, because when it refreshes everything, all the tables and materialized view that are in that group are the ones that will get refreshed. All right, now we can check to see some information about those registered items. And if we take a look here, here's another data dictionary view up here. You can see in my from clause, and I'm doing this, I'm selecting information from there based on the group ID, and I'm getting the group ID in that DBMS sync refresh package. There's a function called get group ID, and I just pass it the materialized view name. It gets the group ID for that, plugs it into the query, and now you can see down here the results of that. Just kind of, again, this step would be optional, but I like to do it at least as we're setting up things. Obviously, as you get this set up and make it part of some process, you may put it here, maybe not. I would probably still put it there just to kind of give me some information about the process. In case the process fails, now I've got the information available to me. So here it shows there's the materialized view, there's the two tables that I've registered, and they're all under the same group ID. And I could have printed that out there too, but I didn't in this case here. Just another kind of a checking optional step here. All right, and once we've done that, everything is set up for the synchronous refresh as far as, okay, now we can go ahead and start accepting changes, inserts, updates, and deletes at this point. Okay, so you can see here, here's 3 examples that I've done here. Remember, when we do inserts, updates, and deletes with the synchronous refresh, we're doing it against the staging tables, not against the real tables. Even if we try it against the real tables, remember what I said before, that will fail. Okay, so here we have insert into, and we need to remember the staging tables from before. So as you're building this process and you're gathering the inserts, updates, and deletes, remember that's the part from the slide earlier that said the controlled inserts, updates, and deletes. So programmatically we might be doing this. These staging tables are exactly the same as the real database tables, with the exception of they all have an additional column. You can see it here on this slide called DML type $. And what that column represents is just the action against the table: insert, update, delete. So here I'm just doing 3 inserts. So notice here in my values clause I have an I. Okay, so I'm just doing an insert. If you were doing a delete, it would be a D. An update is a UO or a UN. They have an update old and an update new type of thing there, but you can do an update with a U there with an O or an N. So we just tell it what the action is, and then we put the actual data here. So I'm going to insert into the time dimension table this date, March 8th, 2016, and the month will be a 3. And then the other 2 are inserts into the sales fact table. Okay, so I'm putting 2 new sales transactions into the fact table. I'm putting in a March 8th for $4,500, and I'm putting in a March 8th for $1,500. Okay, at this point, all the changes, these could be 3 among millions of changes, they're all just going to the staging tables. So the real database tables, and if you were to query the real materialized view, they don't reflect these changes yet. At this point, we're just gathering the changes, putting them into the staging tables. Okay. Then at some point, when we're ready to do the actual refresh of the real tables and what the real materialized view is, that's when we'll finish off this process, which we're almost there, so hang in there. Okay, so changes come in, we process those against the staging tables. All right, now once we're ready to apply the changes, we have to do some preparation first. So we have to do the prepare staging log first. Out there, so we'll do it for each table that's getting changes, and for the materialized view, we'll see a little bit later on, but here we're going to do that. We have to do the tables first. So we'll do it for the sales fact table, we'll do it for the time dimension table. We have to do it for the tables first, and then we can do the materialized views at that point. Okay. Now, when we do the prepare staging logs, this, like I mentioned before, remember it's kind of a two-step process. Prepare and execute. All right, this is the prepare part here. This is the part that could take a little bit longer to run than the execute, depending on how many changes we have. It's going to do some validation. It's going to do collect statistics on the data and the staging logs, and a number of other things in there. But that's what he's doing this time. So we have a lot of changes that could take a little bit of time to do. Now, once we prepare the staging logs related to the tables, then we can go out again. This would be an optional step at this point, but we can go out against another data dictionary view, this user synchronous refresh statistics log stats, and it'll tell us some information. Here's the statistics that we just gathered with the prepare the staging logs. You can see on the fact table, I'm going to have 2 inserts. You can see on the time dimension, I'm going to have 1 insert. This is just another way to kind of say, what am I getting myself into when I do the refresh, or down the line here, some of these other steps. So another optional step there, but a handy one. I would put it in my process here. And like I said, these steps are really good. You'll want to do every one of these in your process if you're going to set something like this up. All right, so we've done that. We've got that up, the staging logs prepared. So let's look at, here's some of the data before we do the actual refresh. And I'm just about to the end here, so again, hang in there. Notice here's my time dimension table, or this is my fact table, I'm sorry. Here's my fact table. Notice there's no March 8th stuff in the fact table at this point. I haven't applied the changes from the staging log, so this is what we should have expected here, right? So you can see what's in the fact table. There's some dates, there's some sales, and so on. This isn't all the data, but this is just some of the data there. Okay, and this is actually, I said from the fact table. It's from the materialized view based on the fact table. I'm sorry about that. Because I noticed here on February 5th, if I went back and looked at the raw data, I'm familiar with the raw data in the fact table. There's actually 2 transactions on February 5th, one for 2,000 and one for 100. So the materialized view is summing those up by date. So that looks good there. So this is the materialized view data before the refresh. So we don't see the March 8th stuff in there yet. Okay, at this point now we're ready to prepare the materialized view for the refresh. Okay, remember we had already done that for the tables, and now we're going to do it for the materialized view. We did a few checks in between just to make sure everything looks okay. So here we're going to do a stored procedure called prepare refresh based on a group ID. And it's going to go out and do the preparation for the materialized view. Now the main thing it's doing for the materialized view, remember the materialized view has to be partitioned the same way as the fact table that it's based upon. So what he's doing here is he's mapping up the partitions between the fact table and the materialized view and the materialized view staging log. He's mapping them together. So he's basically putting in some pointers, getting everything organized, getting ready for the execution of the refresh. Because remember, with the materialized view, which is based on the fact table, if we have a lot of changes, what makes this very efficient is when we apply those many changes, he does, like I mentioned earlier, the partition exchange between the staging environment and the real environment. And so he has to map those all up, and that's what he's doing here. Okay, just remember this, the order of these steps is important. Okay, if that goes well, we can come out here, check, we can check on it. Obviously, if you run that and you don't get an error message, you should feel pretty good about it. But you can go out and check it. There's another data dictionary view here, the user synchronous refresh group status. I can see that it's complete. If it had failed, it'd give me a status indicating that it had failed there. But this is just another way to tell if it went okay. All right, and then done. Now we're finally to the execute refresh here. So everything's been prepped. We've gathered statistics and everything in the staging areas for the tables and the materialized view. The real database tables and the real materialized view data, those haven't been changed yet. And that's what's going to happen here when we do the execute refresh. And again, remember, on the materialized view, he's doing an exchange of the partitions. If there were any dimension table changes, he'll do those also. If this is running and it's taking a long time or whatever, it's good to identify what the group ID is ahead of time, because you can always do, there's also a procedure called abort refresh. You could cut that off at that point in time, but when this whole process gets done, if it gets done successfully, there's also a procedure called unregistered materialized views if you want to go back to the or non-synchronous refresh like it looked before. So when this gets done, it's doing everything at the same time. He's refreshing the tables, he's refreshing the materialized view. When this step is done, they're both refreshed out in the real world there. If we take a look here, this is a process that I've run through. If I look at my time dimension table here, there's my new, I remember I had an insert from March 8th into the time dimension table. And now if I do a query against it, it's there after the execute refresh. And here's the big thing. If I look at the data in the fact table after the refresh, there's my two values there for March 8th, 4,500 in sales on March 8th, a different transaction for 1,500 on March 8th. So those are in the fact table there. And then if you remember what the materialized view is supposed to do, it's supposed to sum up the sales by date. And so if I take a look at that here next, we're all just confirming now that the process actually worked. There's my March 8th for $6,000, which is the sum of 4,500 and 1,500. And you notice up here I'm doing a select from my materialized view up here at this point. And the process is done. So if you remember, I went through a number of steps there. So again, get yourself a copy of these slides so that you have a copy of the order of the steps there and what's required and what's optional along the way there. Now, along the way, there's a lot of errors or exceptions that could pop up. These are just some of them that could come up here. Staging log does not exist on a table. That was one of our first steps that we did in this step-by-step process, was the staging logs there. So we need to make sure that gets in place there. A table does not have a staging log. A materialized view has not been registered. Okay, so like I said, the steps are important. If you skip a step, I'm going to let you know. If you skip a step or there's something about the step that you didn't quite do right, you put in like the fact table name instead of the materialized view name. The error messages, they're hard to find information about, for one thing, because this is still a new feature. And two, the error messages are a little bit confusing with this one. Okay, these all look pretty clear here, but there's other ones that could pop up too that I've run into that are certainly not some of their best work as far as error messages go. Okay, so if you remember what this feature is all about, it's really a new process. The process is you're gonna have like a warehouse environment or an environment which isn't updating, inserting, deleting data, boom, 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 like a transaction database would. You're going to have materialized views, you're going to have fact tables, you're going to have dimension tables. It's intended for that environment. Remember, every new feature isn't a good feature necessarily, and every new feature is great as long as you use it as it's targeted or intended to be used and not some other way as well. So keep all those things in mind. There's a new package called DBMS Sync Refresh. Remember some of the rules along the way about partitions have to be there. They have to be range or composite partitions. Now, I think this is the biggest change in there. You're making those changes against the staging tables and not the real tables. And those staging tables hold all the changes until you're ready to process them. And that's the controlled part. The periodic part would be, when are you going to process them? Nightly at 2 a.m., on the weekend, when are you going to do that? So that's what this particular 12C new feature is intended to be. Like I said, I think it's a new process because it's not just a change to a command or an option added to this or a change to that. It's a multiple step thing that has to be put into place in order to take advantage of faster refreshes on your materialized view. Remember, that was one of the benefits. And those changes being made to your tables and such all being done in sync. Okay. And that's what that feature is. So again, you have to decide and judge for yourself, is this a good feature for my environment? Do I have a need for something like this? Maybe not today, maybe you will later, maybe not at all. All right, remember, if you have any questions, I got a few things to wrap up here. If you have any questions, send them to jmullins@themussync.com. There's some upcoming webinars coming up. First one's on DB2, access path stability, best practices. That'll be on January 30th. And then, hey, we have another Oracle one coming up on February 15th. This one's kind of interesting. This is a little bit different way that we've been doing webinars. Between now and February 15th, if you get an email, it'll explain it all to you there. But you could go out also to our website and go to the webinars and see the details about it there. What we're doing is we're gathering your questions. I want to hear from everybody out there. What questions on your mind? What kind of problems are you running into? Send those all in to me at jmullins@themussync.com. And what we'll do is, as a group here at Themis, we'll go through all those that we get, see how many we can fit into a 45-minute time frame. We'll take a variety of those, both SQL, PL SQL, beginner, intermediate, advanced, administration type questions. Fit them all in there. And if your question is chosen to be part of the presentation, you'll be entered into a drawing for a $100 Amazon.com gift card. Okay, hey, that's a pretty good chance, right? So if you're chosen, there's going to be, I don't know, probably maybe 10 questions that we can fit into 45 minutes. You have a 1 in 10 chance of getting a $100 gift card, so that's pretty good. If you send in your question and it's not chosen, doesn't mean it's not a good question. We'll still answer those questions, so we'll give you an answer back via email on those as well. Okay, so remember that one there. Just go out to themussync.com/webinars for that information there. That'll be fun, I think. It's kind of like a radio call-in show. Hey, I got a question. What do you think about this? Any authors and companies for those questions will be kept anonymous during the presentation. So I'm not going to say, hey, I got a question from Jim Davis at IBM and wants to know about this. I'll just bring in the questions, and we'll know who you are from your emails and such. Lastly here, for more information about anything out there, go to themussync.com for training on Oracle, DB2, Linux, Java, whatever. You can get a copy of today's presentation. The slides should already be out there, themussync.com/webinars. And the recording of today's webinar should be out there in a day or so. Okay, it takes a little bit of time to process it and reformat it to put it out there. If you do have information about or have questions about training needs, all our training courses are customizable as well. So if you look at the outline and say, well, they don't talk about this, or I don't really want them to talk about that, for those private types of trainings that are out there, we can customize those for you. And you can talk to John Kakaval about that. He's a good guy, easy to work with. He'll take your questions and get back to you as well. There's his email address at jcac@themussync.com. All right, so that's today's presentation. I think that's a pretty good feature. I think but it fits in only certain types of environments. Get a copy of the slides so you have an order of the steps that are necessary. Try it out in your environment. See what you think. If you're doing something different without the synchronous refresh, but it's basically the same results, try it with this and compare the performance and see what you get as well. All right, thank you everybody for attending. Everybody have a good rest of your Thursday and a good rest of your week. And you got the weekend coming up. Enjoy that. If you have any questions, send them to jmullins@themussync.com about technical type questions, including today's webinar, or if you have questions about course topics and such, or scheduling, talk to John Kakaval. Thank you again, everybody, and I'll see you again in the future at another Themis Inc. Oracle webinar.